Hey, Lily. Nobody's here. It's just you and me. So I don't know if you want to work on the math packet or if you just want me to go through all these problems with you for homework.
I might want to go through these problems.
Okay. All right. Well, let's do them one by one and you'll have your homework done too. So
What?
if you need to work on something else, you can turn that math packet in next Monday if you want to.
Are you sure?
Yeah, that's fine. Just yeah, I mean, I'm totally fine with that. I realize that it's it's kind of intensive, but if I didn't feel like it was really, really important to later things, like really understanding graphing and really understanding systems of equations and learning how to manipulate linear equations that have two variables in them is just so important for the next 2 years of your math.
Uh-huh.
So it is an important exercise, I promise. I'm not trying to torture you with no purpose behind it. Anyway, but let's work on the homework. You got it?
Yeah, I'm just
You
making
so you're
that.
ready to go? All
Yeah.
right. All right. Have you done any of them, sweet girl?
No, ma'am.
Oh, okay. All right. Well, then we'll start with one. I just didn't want to bore you and start with ones that you'd already done. That's my purpose in it. I don't care that you haven't done them. It's not a big deal. Okay, so number one, let's take a look at it. So the key thing when you're looking at any expression that has an exponent to it is to ensure that the bases are the same first and foremost, because that's the only time that the rules really apply. Okay. So looking at 3 squared times 3 to the 6, the bases are the same because they both have 3's as the base. So all you have to do is add, because they're being multiplied, you add the exponents. So 2 plus 6 is
8.
8. So that answer to the first one is 3 to the 8th power.
Mm-hmm.
So that's that one. Okay.
Okay.
Like that. Except yours probably looks prettier.
No.
It almost looks like a 38. Help me, Jesus. Okay. Number 2. Now this is a power raised to a power. So in this case, and there's only one digit, but all you need to do in this case is multiply the 4 and the 3. Because when a power is raised to a power, you no longer add, you multiply. It just kind of goes up because an exponent is a little bit higher of a property than multiplication. It's like addition, multiplication, and then powers. I kind of think of it as a stair step. So this time you're going to multiply the 4 and the 3. So what is that?
12.
So the answer would be 5 raised to the 12th power. Okay?
Mm-hmm.
Number 3. On this one, both of the things that are inside the parentheses, that 7 that's on the outside, they're both being raised to the 7th power. Okay? So it's 32 to the 7th power times, that doesn't make a dot on here very well, 14 to the 7th power. And that's your answer. It's just letting you know when multiple things are being multiplied by inside the parentheses that you raise both things to the power that's on the outside of the parentheses. Does that make sense?
Uh-huh.
Okay, number 4.
What was the answer for that one?
That was it. 32 raised to the 7th times 14 raised to the 7th. You don't have to go any further than that.
Oh.
That's it. That's the answer. They're just showing you shortcuts of how to write certain things. Okay?
Uh-huh.
All right, so number 4. There's 3 7s there. They're all the bases. So all the bases are the same. So I'm going to add all of the exponents But the key thing to remember there is what is the exponent on the 7 that's all by itself?
1. So it'll be 7 to the ninth.
Yes, ma'am. That's the answer. You got it. 7 to the ninth power. Okay? All right. Number 5. What is the understood exponent outside the first -4?
1.
Yep. So that's -4 to the first power times -4 to the ninth power. So what's the final answer?
-4 to the 10th power.
And it has to be written just like this. Okay?
Okay. Why do the parentheses have to be on the outside of the 4?
Good question. Very good question. Because this right here is -4 times -4 times -4 times -4. If it was on the outside like this says whatever my answer is here, this means opposite of. This actually over here, that actually means -4.
Okay.
So, so that we can understand it a little bit better, I'm going to reduce this to a smaller power because you and I both know what 4 squared is. This is -4 squared. So what's -4 times -4?
-16.
-4 times -4. Think about it. -4 times -4.
Oh,
It would be a positive, wouldn't it?
mm-hmm.
16. But 4 times 4 is 16. And this right here says it's the opposite of whatever that is. So what's the opposite of 16?
-16.
Yes, ma'am. So this one is -16 and this is +16. Does that make sense? Or no, not really.
So the final answer is -4 to the 10th power.
Yes, ma'am. In parentheses. Make sure that that -4 is in parentheses.
Yes.
Okay. All right. Now, number 6, we're starting a concept of quotients. And with division, that correlates to subtraction. So you first want to check and make sure the bases are the same, which they are. They're both 7. And the top one is raised to 12 and the bottom was raised to 4. So you would subtract. So 12 minus 4 is what?
8. So 7 to the 8th power.
Yes, ma'am. So 7 to the 8th power is your final answer. Okay. Number 7. Check to make sure the bases are the same, and they are, and it's -9 inside parentheses. The top one is raised to the ninth power, and the bottom one is raised to the 7th. So you'd subtract the two exponents, 9 minus 7. So what's the answer?
Parentheses for the -9 raised to the 2nd power.
Good job. All right, now on this one, all the bases are the same, but we've got some working out to do. So you want to take it step by step. So the top is 3 to the 7th times 3 to the 4th, all over 3 to the 6th. So you want to take it step by step. So at the top, we've got two things multiplied. 3 to the 7th times 3 to the 4th. So what do we do with those two exponents?
Add.
Yes, ma'am. So that's going to be 3 to the 11th, correct?
Mm-hmm.
So now we have 3 raised to the 11th power over 3 raised to the 6th power. And now what do we do?
You would subtract, so it'd be 3 to the 5th power.
Yes, ma'am. So my final answer is 3 to the 5th power. Doing good. Okay, number 9. what you want to do on this is when the fraction is on the inside, you want to make sure that you understand that that 4 on the outside applies to both the numerator and the denominator.
Uh-huh.
Um, so on this, to simplify that, the 5/4 raised to the 4th power is 5 raised to the 4th power over 4 raised to the 4th power. And that's your final answer.
Uh-huh.
Does that make sense to you?
Yes.
Okay, good. All right, number 10. Basically the same concept, but they're just adding some letters to us. But if you check and make sure that the bases are the same, and on number 10, it's got a base of x on both of them, x raised to squared and then x to the 5th. So all we need to do is add those exponents. So the final answer is what?
X to the 7th.
It is. Good job. Number 11. Okay. Remember up here how the 7 applied to everything that was being multiplied inside the parentheses. Please know that 3x cubed, that's 3 times x cubed.
Uh-huh.
So this 2 applies to the 3 and it applies to the x cubed. So
Uh-huh.
what is 3 squared?
9.
Yep. And now when an exponent is raised to another exponent, what do you do with those?
Add.
When the exponent is raised to an exponent, what did we do up here?
Multiply.
Yes, ma'am. So 3 times 2 is,
6.
so that's your final answer for that one. Did that make sense?
For the most part, just like having 9x and 6 all in the same place kind of confuses me.
Oh, it does?
Uh-huh.
Okay. So help me to help you. How could I clarify that for you? Should I have on this step maybe made a second step and done 3 squared and then x to the 6th so that you knew that the squared went to here and it went to here?
No, I think it makes sense now.
Okay. Or it's just what you're saying is the numbers all written like that are kind of ugly. Is that it? Because there's so much going on. Um, okay. So number 12. Here's one that we were talking about. Remember, you were kind of asking me what's the difference between the minus being on the inside and the minus being on the outside? Remember we talked about that?
Yeah.
Okay. So here we're going to get to see some of those differences. So I've got the minus on the outside, but inside that square, that it's going to be 7 squared x squared because this squared applies to both. Okay.
Okay.
And now what's 7 squared?
49.
And then x squared. Now what it's saying is what is the opposite of 49x squared?
Negative 49x squared.
And that's it. That's your final answer. Does that help you see what the difference is between being on the inside and being on the outside?
Yes.
Okay. Number 13. Six x to the 5th times x. Okay, that 6. Do you have your calculator with you?
Yes, ma'am.
Okay, cool. That 6, remember this 3 here on the outside of the parentheses, that 3 exponent is applied to everything that's on the inside of the parentheses. So you've got 6 cubed x, and then you would multiply the 5 and the 3 because that's a power raised to a power. So what's 5 times 3?
15.
15 times x. All right. And so what is 6 raised to the third power?
216.
So then that's 216. And then this is x to the 15th times x raised to, what's the understood coefficient on that x?
1.
Okay, so what's when you have x to the 15 times x to the first, what's my final answer going to be?
X to the 16.
So the final answer will be 216 x to the 16. Did you get that?
Yes.
And do you understand it okay?
Yes.
Okay, good. That was 13. And now there's a lot going on 14, but don't let that intimidate you. Just take it one step at a time. Okay, so let's write the problem out. 2x to the 5th all raised to the third power times 7x to the 7th all squared. Okay, so on the first set of parentheses, we'll take that. And remember that cubed, or that 3, applies to everything on the inside of the parentheses. So what is 2 cubed? That's 2 times 2.
8.
Yes, so it's 8. And now when you have a power raised to a power, what do you do with the exponents?
Add.
When it's a power raised to a power?
Multiply.
Yes. So when it's multiplied, when it's 2 things multiplied, you add. When it's a power raised to a power, you multiply. Are you seeing the difference?
Yeah.
Okay, now on this second set of parentheses, so I'm just going to put that in parentheses, but we finished it. That piece right there, okay? On this second set of parentheses, we have to remember that that squared applies to everything on the inside of the parentheses. So what's 7 squared?
49.
Okay, now this is the x is a power raised to a power. So what do?
Multiply.
Okay, so what's 7 times 2?
14.
14. Now, this is x to the 8x to the 15 multiplied by 49x to the 14. So what's 8 times 49?
392.
392. Now, when 2 things are multiplied that have the same base, which we've got an x to the 15.
You would add?
Yes, you add. When it's multiplied, you add. When it's a power raised to a power, you multiply. But when it's x to the 15th times x to the 14th, what's that going to be?
29.
Good job. So that's your final answer. 392 x to the 29th. How was that?
A little confusing, but I think I understand it.
Yeah, it is confusing, but if you look, it can be confusing. Just take it one little step at a time. All right? And don't this is definitely not an area you want to skip steps. Okay, so the next one, we have 1 over x raised to the 9th power times x to the 21. But since this is a fraction here, I'm going to express it with a 1 underneath. Does that confuse you?
No.
Okay. So all you're going to do is multiply straight across. What's 1 times x to the 21st?
X to the 21st.
And what's x to the 9th times 1?
X to the 9th.
So what's 20? And so now this is a quotient. So what do we do?
Subtract.
So what's 21 minus 9?
X to the 12th.
So that's your final answer.
Yes.
How was that one?
That wasn't too bad.
Not too bad. Okay. Did anybody join Math Lab or is it just still you and I?
It's just us.
Okay. I can't see the little chat bar or the Google room when I'm working in here, and that's the reason why I ask. Okay, now this one we've got a negative on the inside of the parentheses. So that's going to tell us that our final answer because the exponent is odd is going to be negative. We've got -4 over x. That exponent, the 3 exponent, it gets to applied to everything on the inside. So that's going to be 4 raised to the third power all over x raised to the third power. So what's 4 raised to the third power?
64.
Uh-huh. Over x to the third. And it's negative. Do you understand why it's negative? Because this is odd. If it's even, it would be positive. Because if you think about it, if I have a negative times a negative, it's going to give me a positive, right?
Yes.
And if I have a negative times a negative times a negative, it's going to give me a negative.
Mm-hmm.
So if I have an even number of negative signs, it's always going to be positive. And if I have an odd number of negative signs, it's always going to be negative. Does that make sense?
Kind of, yeah.
Because, like, if you think about it, if you have a negative times a negative times a negative times a negative, that's 4 negatives, right?
Mm-hmm.
The first 2 would make it positive. Then this third one's going to make it negative. The fourth one's going to switch it back to positive, right?
Uh-huh.
So, because when you have an uneven number of negative signs, you got a negative. And when you have an even number of negative signs, you get a positive. That's how that works.
Uh-huh.
Did you get the final answer for number 16? I know we switched the subject. You got that? 64, -64 over x cubed?
Yeah.
Okay. All right, number 17. That 6 applies to both things inside the parentheses. So what do you have on top?
W to the 6.
What do you have on bottom?
V to the 6.
And that's your final answer. Okay, and number 18. We've got x cubed all over 4, and that whole thing is raised to the second power. So that applies to everything on the inside of the parentheses. So x cubed raised squared, what's my final answer for the numerator?
X to the 6th.
X to the 6th. And what's my final answer for the denominator? What's 4 squared?
16.
Yep. So that's my final answer. So that's the quiz.
Thank you.
Did it help?
Yes, ma'am.
Okay. Do you want to go back to working on the packet?
Sure.
or do you need to move to something else?
I might have to work on something else.
Okay, well that's fine. You can do whatever you want to, sweetie, and you can have till next Monday. Um, I was going to say, how many did we get through today, baby girl? Do you remember?
Of the packet,
Yes, ma'am.
through number 8.
Okay, so we got through number 8, and I sent you 6 of them. So I was going to say, and it started, I think I started with number 14 on that. So I would say if you could try, what does that leave you? You know, if you did like 4 a day between now and Sunday, you know,
Mhm.
you would be done with the packet. Even that even includes the one I sent you.
Okay.
I think that's right. 17. Yeah. About 4. Yeah, about 4 a day.
Mhm.
That would get you done with the packet by next Sunday. One
Okay.
day would have to have 5 on it, but that would help you get through the packet.
Uh-huh.
So, but I know there's lots of work to be done. So, and even if you want to bring it to class tomorrow, we could even try to hit a couple of them tomorrow. And I can even work with you tomorrow night again if you want to.
Well, thank you.
No problem. You have a blessed day.
You too.
All right. Bye bye.
Bye.